Welcome to the Middleware Tech YouTube channel. In this series, you'll learn about OOPS inheritance. All code examples used in the videos will be available on GitHub. Let's get started.
Using class and object, right? Now we are talking about object relationship. Object relationship means how multiple objects are connected. Very layman's language, we can say like that. Let me say once again, what does it mean by this? See, object relationship is defined in two categories. One is called has a, another is called is a. Is a. Object relationship is defined into two categories. One is called has a, another is called is a. What does it mean by this? Like, so let us understand using an example. Let me give one example for has a relationship. Like, I'm writing here like classroom have chair. What I'm writing here, just see. Classroom have chair. Now, when I say classroom have chair, this classroom is an object. Classroom is an object, right? Classroom is an object because it has attribute and action. Yes. Chair is also an object because it has an attribute and action. Chair is also an object. It has attribute and action. Correct? And have is the name of the relationship. Have, it's a name of the relationship, or you can write contain. So have is a name of the relationship. Relationship name is have. Fine, right? So what I'm saying, classroom have chairs. Fine. Now classroom is an object. Chair is an object. Have is a name of the relationship. So this is how I defined the relationship between two objects, classroom and chair. Fine. Now, why I'm saying has a relationship. Now here, this object oriented, already you know that we can implement using different cardinality. So this one without cardinality we have defined. If I want to implement cardinality, if you know that we have total 8 types of cardinality: one to one, one to many, many to one, many to many, unidirectional, bidirectional. So I'm not going to discuss them here, but if I'm going to implement cardinality in this object relationship, has a object relationship, then we can say like one classroom have many chair. One classroom have many chair. Then what we have done, we have implemented cardinality, relationship between two objects. Then we say that one classroom have many chairs. Fine. This is one example of has a relationship. Okay. Now you'll say that why I'm saying it's an has a relationship. Has a relationship is that one when one object contains some other object, that is defined as an has a relationship. One object contains some other object. Now one classroom have many chairs where chairs are inside the classroom. That's why we define it as an has a relationship. You can define another one example, like, give me another one example, like one book have many pages. You can define like this way also. If you want to define one book have or contain many pages. One book contain many pages. So this is another one example of has a relationship with cardinality, while one object contains some other object. So how we can implement this in Java? Now these things we can implement in database also. So I'm not going into that side. From Java point of view, let me talk about now. Now here has a relationship, how we can implement in Java, correct? Has a relationship, how we can implement. So take the classroom class. So how to implement? Let's see, my class name is classroom. So this is my classroom class. This is a classroom class. Fine. This is an object, right? For this object, I have written one class. Fine. Now I have another one object called chairs. Correct. So create another one class called chairs. Class chairs. A chair. So I have another one class called chair. Right. So we have two class. Classroom object, you have one class. Chairs object, you have another one class. Fine. Now what I'm going to do, I'm going to define has a relationship between these two class. Now see, there is different rules based on cardinality. Okay. One to one, one to many, many to one, many to many, unidirectional, bidirectional. So there is different rules is there to how I'm going to implement has a relationship based on different types of cardinality. Okay. So for the time being, just I will talk about what is has a relationship. So I'm trying to focus there itself now. So has a relationship means one object contain another object. So classroom object contain chair object. How I'm going to implement? Now in this example, you have not implemented any relationship between these two objects. I want to implement has a relationship between these two objects. How? Then you have to create an object of chair inside classroom. You have to use chair ch equal to new chair. The moment you have written this statement, uh, then these two class, you have created a relationship between these two class, and that is has a relationship. Fine. The moment you have created an object of chair inside classroom class, you have created an object relationship between these two class, that is called has a relationship. Fine. Okay, where one object contain another object. Fine. One example. This is called has a relationship. If I'm not going into more than that, this is called has a relationship here. I told you that yes, object relationships are two types. Another is called easy relationship. So let's talk about easy relationship. Now this has a relationship has some name also. Okay, it has a particular name called association. To remember this, it has a particular name called association. Okay, these are some technical names. Association. So association is nothing but a relationship between two object. And these associations also divide into two categories. I think you have heard this association means association or has a relationship is nothing but association, a relationship between classroom and chair. So there is also these associations also two categories there. Okay, or has a relationship. There is a two category. So if you want to say this category has a relationship, let me share some input. So first one is called. So this is two types association. Has two types. One is called aggregation. 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 Another is called composition. Okay, so this has a relationship or association. We can divide into two categories: aggregation and composition. Aggregation, composition. Let me. I'm not going too much here. Aggregation and composition. How are you going to define it? So we can say aggregation is nothing but one special type of association is an aggregation. Okay. Right. Compositions also you can define it as one type of special type of association is called composition. Now how we can differentiate between them? That like as for example aggregation and composition. That aggregation is said to be as a normal association. Just now I talked about one classroom have many chairs. Okay, similarly college have a student. These are some examples of aggregation. But composition is said to be as when one object cannot exist without the other, then that type of association is defined as a composition. When an object contains other object, if the contained object cannot exist without the existence of the container object. Okay, so it is said to be as a, let me write when I'm saying this, normal association, or you can say association. Normal association in the sense I want to say that whatever the associations you are going to define between two objects, when one object contains another object, that normal association is called aggregation. Composition is not that. Composition, if I want to write it properly, then we have to say like when an object contains other object okay, if the contained object, if the contained object, if the contained object cannot exist without the existence of container object, cannot exist without the existence of the container object, that type of association is called composition. Okay, as for example, if you think about college and a student, a class contains student, so a student cannot exist without the class. Think about class contains students. Okay, college contains students, college cannot exist without the student. So this type of association you can say it's a composition, but it mainly depends on how we are going to design. Okay, most of the scenario based on your design you're going to implement, right? Okay, so this is how it is. You can say composition and aggregation. So on the other side, we have another type of object association, that is the easy relationship. Let's talk about this easy now. So another type of object association, that is called easy. So easy have another one name called inheritance. Inheritance. Okay, so let's talk about some point here on easy relationship. So easy is another type of object association, object relationship. Okay, so this from object relationship point of view, if I want to say, then let me give one example. Try to understand how. Now let's see, I have one object, employee. Fine. So employee is an object because the attribute and action is there. I have another one object called manager. Fine. So both are object. Right? Both are object. This is an object. This is an object. Now I want to create a relationship between these two objects, like employee is a manager. Is a manager. And define a relationship between these two object. I can create a relationship. So last time we talked about one object contain another object. Now here also I'm talking about object relationship that is called inheritance, where this is my object. Employee is an object, right? So I can create a class employee employee. So it's a class, correct? Fine. Similarly, I have another one class that is called manager. Fine. So class manager, correct? So I have two class. Now what I want to do, I want to create an object association between these two objects, and this association is called inheritance. So what I'm going to define, like employee is a manager. So how I'm going to define? So employee have all the properties plus manager have some space properties. So you can write like a manager extends employee. So the easy relationship we implement using this extends keyword, where employee is a base class and manager is a derived class. It has its all the properties of employee plus it has his extra property. It is inheriting all the properties from the base class plus it has its own property, right? So like this way in Java we can implement the easy relationship, right? So right, okay. So if I have any instance variable here, int empid, so that is by default available here because you are using this extends keyword, right? So it will be available inside this manager class, because in case of easy relationship, this is called derived class. Derived class will extend all the attribute of the base class plus it will have its own attribute. Fine. So they like this object relationship, two types of object relationship we generally implement. One is has a relationship, another is easy relationship, how we can define. And so in case of easy relationship, always one object will inherit the features from another object. So there is a concept of base class and derived class concept. Whereas in case of has a relationship, one object will contain another object, right? Okay. So this is how we can talk about object relationship, right? Okay. So let's talk about an OOPS concept point of view. We are talking about OOPS concept, right? In Java, we are talking about Java is an object-oriented programming language. When I say object-oriented programming language, it has some features like class, we talked about last day, like object, we talked about last day. Today we are talking about another one features for object-oriented programming, that is called inheritance. Fine. So let's talk. So inheritance is one of the OOPS concept, right? So we use this concept in object-oriented programming approach, and we should explore inheritance into more how Java is going to implement inheritance and what is the advantage of using inheritance in Java, and right. So we'll explore on this more. So you're following this part, right? Right. Okay. So let's write some code to explore this inheritance part. Fine. We have some other OOPS concept also. I'll come one by one. I'll add all the things one by one. So now what I'm going to do, how I'm going to, when talk about OOPS concept inheritance, let's write one code to understand this inheritance into more detailed way. So assume you have one class. Assume you have one class name is this. This is one class. Fine. So since we're talking about OOPS concept inheritance, so assume it is a base class. Fine. Okay. I have another one derived class is there. Class B extends A. So this is a derived class. Fine. So this is the base class, the derived class, and using extends keyword, you are going to extend the features of base class to derived class. Okay. So assume in the base class, you have one instance variable called int a equal to 20. Fine. So when you extend it in the B derived class, so this is your derived class, right? Derived class. Fine. So in the derived class, what we can do, save it. Now in the derived class, I'm going to write void show. It's a method. It's a method in the derived class. Fine. And what I'm going to do inside this method is just printing the value of A, right? So system dot out dot println. I'm just printing the value of A. Fine. So A equal to plus A. It's working fine, right? Okay. Now here, now I'm going to write one derived class. I'm going to write class, main class, right? Main demo, right? Okay. Now here I have one main method, public static void main. Sorry, here I have to, yeah, that you're talking about. This is a main method, right? String args. Fine. It's a main method. It's a main method. Main method like this. Okay. So this is your base class, and a form of this is the base class, and this is the derived class, right? And this is your main class, right? Okay. Now inside this main class, what I'm going to do, I'm creating an object of the derived class. Fine. And then I'm calling obj dot show. It should work fine. It's a normal inheritance, a equal to 20 that you have declared in the base class, right? So that will be available in the derived class, creating an object of the derived class and calling the show method, and it should work fine, no issues. Let me check. It's a normal inheritance only. It should work fine. And your class name is main demo.java or inheritance demo, write it and in demo.java. Let me check it's working or not. Okay, so copy. Okay, and I need to do it in a separate folder. So file save as in demo.java. Fine, save it. So it's saved, right? Now what I have to do, I have to compile and run. So I have to come to the command prompt, cmd cd edit paste enter. Now here you can use javac in demo.java. Compiled, then I have to run it. So Java in demo, enter. I can get equal to 20. So there is no such big deal because this is a base class. You are inheriting it in the derived class, and you're creating an object of derived class, and it's printing. Now what I'll do is that here inside the derived class, I'm going to write int a equal to 30. Just see here, please. The derived class, I have written a int a equal to 30. Now here the scenario, already a equal to 20 is there. Now what will be the value of a? When derived class extend the features from base class, a equal to 20. So a equal to 20 is already available inside this derived class. Now you are going to write a equal to 30. Then what will be the value of a? It will print the value of the derived class instance variable, or it will print the value of the base class instance variable. Which one it will print? Right? Which one it will print? Right? So this is the confusion. Let me check which one it is printing. So let me check. So I'm just creating this here. Fine. Save it. Let me check which one it is printing. First, I have to compile once again, then run. Now see here, it is printing a equal to 30. It's printing a equal to 30, not taking the value of base class. Now see, your derived class extends a, right? So when your derived class will extend the base class, then the value of the derived base class a equal to 20 is available inside your derived class, but it is giving priority to your local class instance variable, right? So that means this derived class variable value is there, but it is hidden. I want to print that derived this variable value, right? How I can print? I want to print this variable value creating an object of the derived class, right? How I'm going to print? So that means I'm just saying here when base class and derived class, when base class and derived class contain same variable name. See, base class and derived class contain same variable name. That's why the problem. When base class and derived class contain same variable name, then creating an object of derived class, it is not possible to print base class variable value. Then creating an object of base class, it is not possible to print. Creating an object of base class, it is not possible to print. Sorry, creating an object of derived class, not base class. Creating an object of derived class, it is not possible to print base class variable value. Fine. It is not possible to base class variable value because you are going to print, it is going to print your current class and variable value. Base class variable value become hidden, right? So that means what? That means base class variable is hidden. Base class variable is hidden. So when variable hiding is a disease, when variable hiding is a disease, then super is cure. Fine. So how it is? The thing is that the point is that what is the problem? Problem is that base class and derived class contain same variable name. When base class and derived class contain same variable name, then creating an object of the derived class, it is not possible to print base class variable value. It is hidden. So how to print this base class variable value? To print base class variable value, we have to use super. So here we have to use super dot a equal to super dot a If you write like this, then it will print the base class variable value. So let me check it is working or not. Control-C copy and paste it here once again, the same code. File save, right? Let me compile and run once again. Compile, run. Now just see here, equal to 30, it's taking base derived class local variable. Means current local variable. I am not saying local variable. It is providing to its current class variable. It's printing the current class variable value. Now, if I want to print the base class variable value, I have to use super.a. If you use super.a, then you can get the immediate base class variable value. So that is the use of super. So super, I'm talking about this topic, that is super. So this super, it's a keyword in Java. It is a keyword in Java. This is some points about this super we talked about, right? Okay. So using this super keyword, now what I've done, super.a, this is one of the scenario. This is the scenario where I'm to use super keyword. Now, super keyword is used to call not only base class variable, you can call base class method also using super keyword. So you can write another one point. Using super, we can call base class. I've given one scenario in which scenario I need super keyword, base class. Using super, can call base class variable and method. Fine. So this is all about super keyword in Java. Yes, you have any queries, you can tell me, anyone, please. This is all about, this is the scenario why I use super. Fine. Okay. Now, so just execute in your system and check it's running in your system. Okay, guys, so let's move to the next part. Next, we'll talk about another one part, that is we'll talk about super function.
Hello.
Please tell me.
Yeah, I have one question in this code which we have written. Suppose you have created the BB class object, right, in the main method.
Yeah.
So you have written like BB obj equal to new AA, and you are trying to print the variable value A, like obj dot A. Then what will be the output? It's 30 or 20.
Okay, you are saying new AA.
Yes. BB obj equal to new AA.
Now see, we always use the scenario like superclass reference point. Now we have not talked about it. Superclass point reference will always point to derived class object. Now in this case, you are saying that derived class object is pointing to this. So okay, fine. So let me check. Just see here. So you can use here AA, file save, compiled. So just see here, in compatible type, AA cannot be converted to BB. So the thing is that we cannot write like this. Always, we have not talked about it, that DMD part. DMD part we talked about when we'll talk about polymorphism. So we always use superclass reference will point to derived class object, not derived class object will point to superclass reference.
Okay.
So this approach we not used. We always so that we'll talk about in polymorphism. Always we have to use this approach: AA obj equal to new BB. Now here superclass reference is pointing to derived class object.
Okay, fine. Yeah, thank you.
This is the scenario. Okay, now let's move to next part. Next, you're talking about super function. So we understand that super function in case of inheritance, how we can use it, why I'm going to use, how and where, all the things we'll talk about this super function. Just see here, please. Here, assume I have one class. Let me understand the super function writing a particular class. Okay, so I have one class. Name of the class is this class. Okay, and inside this class, I have instance variable, three instance variable. One is int x, comma int x. I have three instance variable. Assume int y, then int z. So I have total three instance variable inside this class A. Fine. Now here, I have one. I'll take two instance variable, and I have one default constructor inside this class. Already you know what is this constructor. And I have one parameterized constructor inside this class. Now inside this parameterized constructor, I assume int a comma int b. So I have to initialize both the variable. So you can write here x equal to a, and then y equal to b. So this is a parameterized constructor where you want to print both the attribute value system dot out dot println, and here I want to write x equal to plus x plus y equal to plus y. So this is a simple class, and you have default constructor and parameterized constructor. No issues, right? Normal class. Now I'm going to create another one class on derived class. Fine. So class this extends this. This is a derived class. So in the derived class, it will have x and y, plus it has its own instance variable like and z. Derived class contains total 3 instance variable. Fine. Now, now I want to create a parameterized constructor inside this derived class. Assume 3 argument parameter. So this is the first default constructor, right? And then I have to use parameterized constructor. So this is my parameterized constructor. So inside this parameterized constructor, you can use int a, int b, int c. So just initialize all of them here, like x equal to a, y equal to b, z equal to c. Fine. Okay. Now here, this is an parameterized constructor, 3 argument parameterized constructor. So this class will get the instance variable, both the x and y from the base class. Plus it has its own instance variable, correct? And it is going to initialize all the 3 instance variable. Fine. And then it's going to print all of them. So print all the instance variable here. And then the next one, it will come like z equal to z. Fine. Right. Now I want to create a main class. Create a main class. Main demo. Fine. So inside your main class, you should have one main method. Static void main string args. Okay. Now inside this main method, you should start and close. Fine. Okay. Now here what do I have to do? I have to create an object of this derived class equal to new. This I've created an object of this derived class, and then using this object obj, I'm creating an object, right, using parameterized constructor. So I'm going to pass here to pass some argument like 22, 44. Correct? Right. So file save. So this is a normal code that we have written here. Okay, this is my both the class. Let me write in a single page. Now it's visible in a single page. So this is my base class. This is a derived class, and this is my main class. Fine. Okay. And what we have done from the main class is that I am creating an object using parameterized constructor. So let me check it is working or not. It will work. There is no error. it should work fine. Let me check it's working or not. So Control C, copy. So create a different folder. And here I want to create this. File, save as maindemo.java. Save it. Now here, let me compile and run this code first. It should work without any error. It should work. See here, cd package is this. Okay. Now I have to use Java C main demo.java. Compiled and it will run also. No issues. Just see here, please. Working fine, no problem. Now the see here, if you write this now in this example, my base class contain 2 instance variable, right? And derived class contain 3 instance variable. And using that, we are doing it. Now you'll find this. Now the thing is that what is the problem with this approach? It is working fine, no issues on this. But the problem will come when you have minimum, you are going to interact with 50 instance variable in your class. That time you can understand what is the problem. Here you are going to interact with only 2 instance variable, right? Now assume you have 50 instance variable in the base class. Fine. So for 50 instance variable, you have written the constructor to initialize 50 instance variable in the base class. Fine. Now any derived class, once again, if it has its own instance variable, then it is going to once again initialize all the 50 instance variable. So already you have done the initialization for your 50 instance variable in the base class. Then why I am going to do the reinitialization of the same variable once again in the derived class? That means we should reuse the code that is available in the base class. That is the problem. Fine. So already the code that is written in the base class, this code already there. That means here initialization of x and y is already there. What I am doing in the derived class, I am writing the initialization once again. Now in this example, only 2 instance variable, but think about it when you are going to interact with 40 to 50 instance variable in the class, right? Already the initialization is there in the base class, then why I'll write the same code? I should reuse the code. Fine. So how I can do the reuse, how I can reuse the code? You can disable this 2 line. And without using this, you should write one statement here, super function, and you can write here bracket a comma b. So if you write this statement, then it will do the initialization of x and y calling base class constructor. If I am using super function a comma b, then it will do the initialization of x and y of your derived class instance variable calling the constructor of base class. That means it's going to reuse the code that is already available in the base class, right? So that is the point. Using super function, we will always call base class constructor. First point. code super function. It is used to call base class constructor. It is used to call base class constructor using this super function. So let me check it's working or not. Let me check. So this is the file, not this one. So let me check it's working or not. So here I should disable this 2 line of code, right? Without using them, I'm going to use a super function, super a comma b. Fine. So just save it and then compile and run. Working fine. Now if you see here, this time it is calling the base class parameterized constructor, right? So that is we are talking about here, that if you have already the initialization of an instance variable inside a base class, then you should not reinitialize it once again in the derived class. I should reuse the code that is already there in the base class. How we can do it? Calling the base class constructor like this, right? So like this. So what is the advantage then using this super function? Is that we can reuse code inside a class. Fine. Another point is that is the advantage of using super function. Now super can have an argument without argument, same like earlier this. So if it has no argument, then it will call the base class constructor. If it has an argument, then it will call base class parameterized constructor. It has a no argument, then it will call the base class default constructor. Now this super function, if I'm going to control X and make it as a second statement, it will not work. If you make it a second statement here, it will not work. Compile and run, it will not work. Just check. And this, just use this super function control X and make it here. Make it here. V. Fine. Save it and do some compile and run. Compile. Just see here. What is saying that super must be the first statement in your constructor. So that is the point. If you're using super function, then it must be the first statement in your constructor. Control X, Control V. Then it will work fine. You got another one property for super function, that it must be the first statement inside the constructor. It must be the first statement inside the constructor. Okay, fine. So this is only why we are going to use super function. So main purpose of using this super function is code reusability. We should reuse the code, that is already there in the base class. Fine. Right. So these are some of the properties of super function that is used a lot. Fine. Okay. So just see here where we are talking about